Hello everyone, I am Suhani Patel from MSc1. Today I am presenting seminar on CHO 150 Organic Chemistry Section 1 on the topic of synthesis of pyridine. So let's know about pyridine. So this is a structure, and in this seminar we will synthesize this pyridine. Pyridine is a basic heterocyclic organic compound with the chemical formula C5H5N. Its structure related to benzene with one methane group is replaced by hydrogen atom. So, as we know the structure of benzene, it contains 6-member ring and 3 triple bond. So, as we replace CH by nitrogen, the structure will called as pyridine. It is highly flammable, weakly alkaline, water miscible liquid with a distinctive, unpleasant fish-like smell. Pyridine is colorless, but older or impure sample can appear yellow. The pyridine ring occur in many important compounds, including agrochemical, pharmaceuticals, and vitamins. So, the first major synthesis of pyridine derivatives was described in 1881 by Arthur Rudolph Hantzsch. Hantzsch's pyridine synthesis typically uses a S to 1 mixture of beta-keto acid and aldehyde and ammonia or its salt as the nitrogen donor. First, a double hydrogenated pyridine is obtained, which is then oxidized to corresponding pyridine derivative. So in this synthesis, first is formed double hydrogenated pyridine. After the oxidation, it will form pyridine derivative. Emil Covenzel's show that asymmetrically substituted pyridine derivative can be produced with this process. So let's see the reaction. In the reaction, 2 mole of beta-keto ester is react with aldehyde and ammonia. Beta-keto ester is also known as acetoacetic acid in the presence of water molecule, and this reaction is reflex for 1 hour. Then it will form double hydrogenated pyridine. After the oxidation in presence of FeCl3 and reflex for 2 hours, then it will form substituted pyridine. Now we will see a mechanism. In the mechanism, there is a 2 intermediates formed. First intermediate is formed by 1 mole of beta-keto ester is react with aldehyde molecule, and the removal of water molecule take place. So first intermediate is formed. Second intermediate is formed when another molecule of beta-keto ester will react with ammonia, and here also water molecule is removed. Then the second intermediate is formed. In third step, both intermediate will react with each other and they will form double hydrogenated pyridine. After the double hydrogenated pyridine will oxidize and form substituted pyridine. So in this slide you will know how two intermediate actually react. So as we know, in first intermediate NH2 is there. So on nitrogen there is a lone pair. It will shift its lone pair to ring, and the double bond of this first intermediate will attack on another intermediate forming this reaction, and when it will react, this double bond will shift here, and the double bond on oxygen will shift and form negative charge on oxygen. This kind of intermediate will be formed here. And after, as we know, the ammonia is present in our reaction, then it will abstract one hydrogen from NH2 and form NH4 plus. After the abstraction of one H from NH2, it will form this type of intermediate, and after this intermediate it undergo tautomerism and form this type of structure, and in this structure ring cyclization take place and double bond of nitrogen will attack on this carbon and double bond shift on oxygen, and oxygen possess negative charge. After the protonation of O minus, it will form OH and ring will form. After the removal of H2, it will form this type of structure, and further protonation and deprotonation will take place and form this dihydropyridine. After this dihydropyridine oxidation, it will form substituted pyridine. In this way we can synthesize pyridine from 2 moles of beta keto ester and 1 mole of aldehyde and 1 mole of NH3 molecule. In the presence of water molecule, we will synthesize substituted pyridine. Thank you for listening my seminar.